Ever feel like you're just swimming in data trying to, figure out how everything connects? Today, we're diving into a tool that helps bring some order to that chaos. It lets you find hidden links, make sense of complexity, maybe even peek into the future a bit. We are taking a deep dive into regression analysis.
Exactly. And it's important to distinguish it from correlation right off the bat. Lots of people mix them up. Correlation just tells you if two things seem linked and maybe how strongly, like more ice cream sales when it's hotter. Simple association.
Right.
But regression analysis, that goes deeper. It tries to figure out the form of that link, the how. So you move from just knowing things are related to understanding the mechanics of it. And that lets you predict things, maybe even control them.
Okay, so that's our mission today then. To help you really get your head around this powerful tool, we want to show how it gets past just noticing patterns to, well, actually understanding how things work together, turning observation into action almost. And, what's really interesting is where this all came from. It's not some newfangled technique, is it?
No, not at all. Its roots go way back. One of the really famous early examples is Francis Galton, 1885.
Wow, okay.
Yeah, he was fascinated by heredity. He was looking at the heights of adult children compared to their parents. And he wasn't just saying tall parents tend to have tall kids. He was starting to quantify it, like how much taller could you expect a child to be based on the parent's height? It was, well, a really early step towards predictive modeling based on observed relationships.
That's pretty cool. So fast forward to today, what can you actually do with regression analysis? I mean, it's clearly not just academic.
Oh, definitely not. It's everywhere, really. Think about agriculture. You might suspect seed quality affects rice yield, right?
Oh.
Fertilizer. Regression doesn't just confirm that suspicion. It helps you quantify how much impact each factor actually has, maybe compared to rainfall or temperature, too.
Ah, okay. So you can see what matters most.
Exactly. So you stop guessing and start making informed choices. Like, does better fertilizer give more bang for your buck than, say, investing in different seeds? It moves you from just intuition to actual optimization.
That is a big shift. And you mentioned control earlier, not just prediction. How does that work? Can you give an example?
Sure. Think about manufacturing something, maybe welding fabric. You might notice that changing the heat or the pressure affects how strong the weld is. Okay, observation. But with a regression model, you can figure out the precise equation how strength changes with specific heat and pressure levels.
Right, the exact relationship.
Yes. And then you can use that equation to deliberately set the heat and pressure to get the strength you need consistently. You're not just understanding the link, you're actively using it to control the outcome.
That really clarifies the aha moments it can provide, revealing connections and then making them useful. So how does this whole process work, generally speaking, without getting lost in the weeds?
Well, the basic steps are pretty logical. First, you state the problem clearly. What relationship are you exploring? Then, you select the variables you think are involved, the thing you want to explain, and the things you think explain it. Next is data collection. Could be historical records, observations, or even designed experiments where you control things.
Okay.
Then you specify a model, basically, propose a mathematical form for the relationship. You fit that model to your data. And this is crucial. You validate the model, check if it actually works, if it holds up.
You mean check it on new data?
Ideally, yes, or using statistical techniques. You need to make sure it's not just a fluke of the data you happen to collect. And only then, once it's validated, do you use that fitted model for making predictions or understanding the situation.
Got it. And when you say fit the model, I often hear about the least squares method.
Yeah.
What is that, in simple terms?
Imagine you've plotted your data on a graph, like a scatter plot. You've got points all over. The least squares method is basically a mathematical way to draw the single straight line that comes closest to all those points simultaneously. It finds the line that minimizes the overall error, the total squared distances from each point to the line. It's finding the best average path through the data cloud.
So it's literally finding that line of best fit we might remember from school.
Okay.
And how do you know if that line, that model, is actually any good? Like, how well does it capture what's going on?
That's where a key metric comes in, called the coefficient of determination, or R squared. You'll see it written as R.
R squared, okay.
Think of it like a grade for your model from 0 to 1 or 0% to 100%. It tells you what proportion or percentage of the variation in your dependent variable, the thing you're trying to predict or explain, like birth weight. It's actually explained by the independent variables you've included in your model, like, say, gestational age. So a high R squared, maybe like 80%, means your model does a pretty good job accounting for why the birth weight changes. A low one means, well, not so much.
That makes sense. What a journey, really.
Hmm.
From Galton looking at heights back in the 1880s to now, where it's this indispensable tool for making sense of, well, almost anything complex. We've seen how regression helps summarize data, estimate relationships, make predictions, and even enable control in so many different areas.
Absolutely. And, this brings up a really important thought for you listening right now. How could understanding the form of relationships, not just that they exist, but how they work, help you make better decisions in your job, maybe even in your life? What hidden connections are just waiting out there for you to uncover? If you start looking for these kinds of underlying patterns, something to think about.